the last chapter, we solved some absolute value equations, which some of you didn't do too great on. But if I saw something like this, x plus 3 equals 7, does anyone remember how you do that, how you solve that? This is just kind of a review. This is not an inequality. You break it into two parts. In one part, you say x plus 3 equals 7. And the other part, you say x plus 3 equals negative 7. Okay? And then you would subtract 3 from both sides. Okay? And you get x equals 4. And over here, I subtract 3 from both sides. And I get x equals negative 10. And then if I plug 4 in here, I get 4 plus 3, which is 7. And the absolute value of 7 is? 7. Okay? And if I took negative 10, so here you have two answers when you have this type of thing. Okay? And here if I plug in negative 10 in here, I get negative 10 plus 3, which is negative 7. And then I take the absolute value of that, which is 7. Because all absolute value does, you take whatever number is in there and you make it positive. Okay? And that's what absolute value is. It's the distance away from 0. Okay? And so what two numbers, if I add 3 to them, their distance away from 0 will be 7, or something like that. That's kind of what it says. But you have two answers for that. Okay? So now we're going to switch to inequalities, which is much more fun. So if I have something like this, n minus 1, let's have a new, no, let's have, so I have something like this, n minus 1 absolute value is less than 3. You do a similar thing, okay? So what this means, it means in words, all numbers whose distance from 1, that's a 1, is less than what? 3. Okay? So all numbers, so what it means is all the numbers whose distance from 1 is less than 3. Okay? So you can even kind of solve this by doing it graphically. Okay? Say I were to draw a number line. Here's a number line. Ooh, that's not very big. I don't like that color. Let's change it. Let's change that number line to yellow. It's not good. Let's change it to blue. Let's change it to a solid line. Solid line. Do we have arrows on the end? Arrows on the end. Oh, really? Okay, so here's a better number. Oh, that's kind of purple. Okay, so here's 1, right? Here's 1 over here. Where are all the numbers whose distance from 1 is less than 3? How far would I have to go this way in order for that distance to be less than 3? How far away? What would this number be? How, if I want this distance to be less than 3, what would that number be there? Not 2. 1 plus what will get you to, 1 plus 3 will get you to where? 4. Okay? And where do I go to over here? What are all the numbers that are 3 away from 1 on the left side? If this is 0 right here, say this is 0, how far would I have to go to get 3 away to the left of 1? Huh? Not negative 3. This would be negative 1, that would be negative, that would be negative 1, that would be negative 2. You understand that? Because this distance from here to here is 3. And this distance from here to here is also 3. Okay? And then this is the open circle here. So these are the points I am talking about. They're all the points whose distance from 1 is less than 3. Now I could write that as, how could I write that? Some of you guys had trouble with this on a quiz. X is what? Well, less than or greater than 4? Less than 4 and greater than, well, -2. That's how I write that in above. Okay? Oops, I should say n, not x. Sorry. Now, that's kind of confusing, I know, but I kind of wanted to show you graphically what it means before I solve it. Now, the way that you solve this is you break it into 2 parts. So what you do is you say n minus 1 is less than 3. You just leave it alone. So you just leave this exactly like this. Or n, whichever one, n minus 1 is greater than -3. So what you have to do is you have to take away the absolute value and leave the thing just alone and solve that one. And the other thing you have to do is take away the absolute value, flip the sign, and make the right side negative. Okay, so you have to do 2 things. So first you just leave it alone, and then you leave it like this. Now I solve these 2. I'm going to add 1 to both sides, add 1 to both sides. And I get n is less than 4, which agrees with what I have up here. See? Okay? And then I have n, I add 1 to both sides, plus 1, and I get n is bigger than, what's -3 plus 1? -2. Okay? And does that agree with this? X is less than 4, or x is greater than -2. Does that agree with this graph? Yes, it does agree. So you say, you should really have an n there, but it doesn't really matter much in this. And that's the way you write it. N is less than 4, and n is greater than -2. Or you could do it like this. N is less than 4, but it's kind of nice to do as a combo. Okay. You see? It's a little tricky, but you just have to remember what to do. You have to take away just leave it alone once, and then the other side, you flip the sign and you make it negative. Now, what if I have something like, where's my other example? V minus 3 is greater than equal to. Are we going to get a worksheet like this? About this?
Yeah.
No.
Why not?
Because we're going to do work out of it. Greater than equal to 4. You basically do exactly the same process. Okay? So, again, what this means is all the numbers whose distance from 3 is bigger than or equal to 4. Right? So you break it into 2 pieces. Either b minus 3 is greater than or equal to 4, or b minus 3 is what? What do I do with the sign? Flip it, or equal to, and then what do I do with that 4? Make it negative. Okay? And the reason for that is because when I take the absolute value of this, it makes it positive, right? And the numbers that are going to make numbers bigger than 4 are numbers that are going to be less than negative. So algebraically, that's kind of why it makes sense. So now I'm going to add 3 to both sides, plus 3, and I get b is greater than or equal to 7, or b, I'm going to add 3 over here, add 3, or b is less than or equal to, what's negative 4 plus 3? Negative 1. Where b is less than or equal to negative 1. And it's useful to graph these, and a lot of times do electric graph. So b is greater than or equal to 7. I put it closed in the circle like that. And then I go to negative 1, and I put a closed in circle like this. Greater than 7 or less than or equal to negative 1. And you might want to try a point just for the heck of it. What's a point over here that I can take? What's a point I can put over here? What's a point to the left of negative 1? Give me a point. What's a point to the left of negative 1? Any old point.
Negative 2.
Negative 2. So if I put negative 2 in here, it says negative 2 minus 3. What's negative 2 minus 3?
Negative 5.
Negative 5. Take the absolute value of negative 5. What's that?
5.
5. Is 5 bigger than or equal to 4?
Yes.
Is 5? Yes. Okay. And if I took a number like 8 and plugged it in here, 8 minus 3 is 5. Take the absolute value of that, which is 5. Is 5 greater than or equal to 4? Huh?
Yeah.
Yeah. Okay. So with the absolute value inequalities, you leave it alone on one side, and then on the other side you write 4, and then you flip it and you make it negative. So let's try a you try. You try. You try. Where's my you try? Okay. You try. You try. See who's going to get the right answer. X minus 5. Absolute value is less than negative 3. Okay? So solve. Oh, does that work? That's not going to work. Let's try plus 3. Because negative 3, any absolute value is always never going to have, there's no solution to it. And get to a plus 3. Go ahead. Solve for S. Here I get my recorder. Okay. Is she first said x minus 5 less than 3, or x minus 5 is greater than negative 3. And you solve those two things independently. First you add a 5, and you get x is less than 8. Or x, you add 5, right? Add 5, and you get x is greater than positive 2. And then again, if I wanted to graph this, okay, which I do, is x is greater than 2. So here's 2. And x is less than 8, and here's 8. And then I'm just going to shade in between. Less than 8. Greater than 2 or less than 8? Yes? Or you could write it like this. You can combine this. If it's in between, you could write this as x is less than 8 and x is greater than 2. So there's that last question on your test that said and or doesn't make any difference. You know, say I had one like this, and you're going to run into these in your lifetime. Say the absolute value of x minus 2 is less than 3. Anyone know what the answer is to that? The absolute value of x minus 2 is less than negative 3. So you might be tempted to say x minus 2 is less than negative 3, or x minus 2 is greater than 3. Is that right? And then I get x is less than, what's that, negative 1, or x is greater than what? 5. Right?
And that's because you added 2 to both sides.
I added 2 to both sides. But x is less than -1 to -3. But if I take that and I plug it in, right? What's a number less than -1? But if I plug in -2 in here, it doesn't work. -2 minus 2 makes -4, and you get out 4. Is 4 less than -3? No. So if you have a negative sign over here, if you have a negative sign on the right, it doesn't work, okay? Because absolute value always has to be bigger than 0, okay? So if you have a negative sign on the right, whenever you see a negative sign on the right, you should say no solution. Because there's no number, when I take the absolute value of it, it's going to be negative. Because the absolute value always returns a positive value. I got to teach you one more thing. You're going to have to class, which you will. It says the ideal diameter of a piston for one type of car is 88 millimeters. The actual diameter can vary from the ideal diameter by at most 0.007 millimeters. Find the range of acceptable diameters of the piston. Okay, so I used to, I worked in an engineering company a couple summers, and they have something they call mil spec. And mil spec means like it's got to meet military specifications because it's going in like rockets or spy devices or satellites or something. So the tolerances, meaning how close it could be to what you want it to be measured at, has to be very, very tight. Okay, so this might be an example of something like that. And cars have gotten more efficient as well because they have been able to make the tolerances more exact. Okay, so this is a case, and you get of that, and what you want to do is set up an equation. The ideal diameter of the piston is 88, okay, and the actual diameter can vary by at most 5.07. So what you can do is you could say diameter, and the way you find out how far something is away is by subtracting. So the diameter minus 88, the absolute value of that has to be less than or equal to 0.007. You understand why that is? Because it could be over 5.007 or it could be under 5.007. Right? And so the way you solve this is just like you solve an absolute value inequality. You get d minus 88 is less than or equal to 0.007, or d minus 88 is greater than or equal to 0.007. And then you add 88 to both sides, okay? And you get d is less than or equal to 88.007, or d is greater than or equal to, you add 88, whoops, that should be a negative sign, negative 0.007. 88 plus that gives you 87.993, is that right? 993. So these are the tolerances, these are the range of cylinders you could have for your car. So if I were going to, for your cylinders that you're designing, so if I were going to put this on the number line, here I have 88.007, and here I have 87.993, and I would shade all the things in between. And so if I have something like 87.82, does that meet the acceptable range of cylinders? Would 87.82 work for my acceptable diameter? For my piston, sorry, for my piston. Does that work? Is that inside of here? No. Okay? So you would have to like take this cylinder, if you're a piston, if you're making it, and throw it in the throw it in the seconds pile or something like that. That's what they do when you go to a store where they're selling like imperfect stuff or something like that. That's why, because they don't meet the specifications. Like maybe it's off by an inch. Like I buy a lot of my clothes at this place. You could probably tell. But I buy